think I got it. So I'm going to get Visual Studio open. And I'm going to open my Manatee app. But first, I'm going to double check my Team Explorer and make sure I'm connected to TFS. Now, one thing I need everybody to check in Visual Studio, under our Tools menu, look at Options. We might have checked this the other day. I want to make sure. Under your options, we want to look at the source control option and make sure it's set to Visual Studio Team Foundation Server. This doesn't really affect anything. It will still throw your source code into GitHub if you don't connect to TFS manually first, but it just makes me feel better that we've tried. So we'll say okay on that one. Now I'm going to check in my Team Explorer. And I especially need to check because oftentimes I'll be connected to somebody else's TFS library, but I'm connected to mine. So I'm going to open my project. I think mine was Manatee app. Is that what we had? Two of them, even though I'm not supposed to have all this duplicate source code everywhere. Now, my application is not under TFS control. So just like you just did, I'm going to go to Solution Explorer and right-click on my solution. Now, when you're checking into TFS, you can check in stuff at any level. So if I wanted to, I could only check in my Manatee Sightings.cs file. That would screw me over really bad when the instructor went to grade my project, wouldn't it? Because that would be the only part of it that your instructor would be able to see. So we want to make sure that we're checking in our whole solution. Now, if I checked in at the project level, the instructor would be able to see everything. It would work. But we really could be missing pieces still, because we know that Visual Studio behind the scenes is setting up system files for us and making connections between those files. We have some back behind the scenes XAML files that are going on. So that's why we want to check in the whole thing. We want all the pieces, not just part of them. So I usually like to do it at my solution level, make sure I get every project in the solution and every file in every project. So I'm going to right click and choose check in, or, oh wait, first I need to add it to source control. I'll choose my folder. And then I can choose check in. I'm going to go ahead and check this in. And I'll say this is our first version of the Manatee app. So it's definitely not finished. Checking it in at this point is just kind of up to me, right? It's not all the way done. It's not ready to be graded, but I want to continue checking in so that I have those checkpoints. I'm checking in now where we left off the other day. If I get it all messed up, something happens, I could go back and revert back to that version so that I wouldn't lose time in trying to get back to it. Is it working? Now for our Manatee app, it was in that PDF document that I sent you. I'm going to get it open. I did have it open, but then I had to restart my computer. So let me find it again. When you open this PDF, if you right click and choose open with Acrobat, Adobe Acrobat, then you'll be able to have a nice PDF document that has links, hyperlinks that you can jump around from chapters in. So here's mine. I'm going to right click and choose open with Adobe Acrobat Reader DC. Now if I just open this, just double click on it and let it open with the web browser that I happen to be using, I'm not going to have any of this hyperlink information. It's going to be really hard to navigate through this PDF. But if I open it using the Adobe Acrobat app, Now we've got some nice links, and we can see all of the chapters and get to everything. We were looking at chapter 7 in arrays. And this project that we're looking at was at the end of chapter 7, probably down here around coding standards. So I'm going to go there to see. Now I need to back up because this textbook, I know that special project was on these pages that are gray. Okay, so there we were with our Manatee Sighting app. We're ready to continue on. Let's take a look at what we have so far.
What page did you end up on there?
About 419 is about where it starts. There's a little bit on the page before, but. So we created an application here. And remember, if you had opened this application using Team Explorer, you had gone to the home screen and you had gone to the Source Control Explorer and you found it and you double-clicked on the solution, you might actually have to open your Solution Explorer to see your code, right? Because it's not necessarily going to open any of those CS files for you to view. So whenever you're opening from that Source Control Explorer, don't forget to use your Solution Explorer to find your project. So ours, we have 2 different class files. According to our PDF document, they gave us sort of a UML diagram, and they said we're going to have 2 class files. First of all, the Manatee Sightings. In a Manatee sighting, we're going to keep track of where the sighting happened, what date it was, and how many manatees they saw. It's so funny, since we started this application the other day, my daughter called and she said she was getting flight tickets to come home in April. And then I talked to her later and she said, well, I was on the airline website to get those flights and I got this weird pop-up and it said I could go to Ecuador for $250 round trip. So she called her friend right away and said, do you want to go to Ecuador for $250 round trip? And our friend said, yes, I do. So they bought tickets to go to Ecuador. And a few hours later, they found out the mom's mom, or the friend's mom, is going to be there at the same time to go to the Galapagos Islands because they're going to the city in Ecuador where you leave from to go to the Galapagos Islands. So she might get to go see manatees. So it's probably because we've been talking about it. She's very excited. Yes, sir.
There's also manatees in Florida.
So yeah, that would be near as fun. I think she wants to see them in the Galapagos Islands. I don't know. She's weird like that. She likes going to those places. So when they see some manatees, we're going to keep track of where it was and when it was and how many they saw. Now in our Manatee Sighting class, we also decided that we need some methods to do some calculations for us and some other things about those manatee sightings. Now to test our class, we're going to create a Manatee app class. This class is going to have some data variables, and it's going to have one method to help us get the data from our user. So that's what we've been working on developing. We left off like a week ago, so that can happen to us when we're working at work too. So let's review what we have so far. First, let's look at our Manatee Sighting class. In our Manatee Sighting class, remember we used the region statements. So if everything is rolled up on you, you might have to expand or blow up some of those things to see that code. We had our private class fields created. We created the constructors that we were told to create to build our Manatee Sighting instances. We created some properties to share our Manatee Sighting class fields with other classes. And then we created a real quick toString method that just output a little bit about our sighting. Yes, sir?
The Manatee app, is it that you put in the announcements? doesn't have any of that code.
Yeah, you gotta extend it down.
You have to
Um,
extract it from the zip file.
I see it now. Yeah, thanks.
Now, let's look at our Manatee app. And that's where we were at first. We don't have much code in there at all. We just created an instance of a Manatee sighting, and then we used the toString method to print out that information. So let's run it, make sure there's no problem, it's all working. We should just see our output of that location. Great. Everybody's okay? Working? Good. Let's add to it. Now, what we're going to do first is update our tester, our Manatee app class, to prompt the user for input, because we can't do much until we have some data. And they want us to create a method called getData to prompt the user for that information. So right here under my main, let's create that new method. Now, because we'll be calling it from our main method, it needs to be static. We're going to use a lot of different ways of communicating data back and forth between our main method and this getData method. The return value that we send back from our getData method is going to be an integer. We're going to use a parameter, though, that is an out type parameter. The only other place we've used this out statement so far is when we're doing a try parse. We know when we're doing a try parse, that out parameter specifies the variable we want to use as output from the try parse. When we use the out parameter in a parameter list like this, we're saying that this variable is one that can be used as input to my method, but also output from my method. And we're going to set up our location to be that way. So if we update that location variable within this method, we'll see that update in our main method. Now, besides that output parameter, we want a parameter, a set of strings as an array, and this is going to be our dates. So let's call that D array. Now, we also want an array of integers that'll be the number of manatees that we saw that day. Let's call it manatee count. Now, in our getData, we're going to use a few variables, not too many. We're going to go ahead and allocate an integer named I and an integer named loop CNT for count. These will control our looping. At the end of our method, I is going to hold the data that we want to return. So I'm just going to go ahead and put in the line of code to return I. It's going to continue griping at me about that out parameter, but at least it quit complaining about not having a return value. All right, so now within our getData method here, let's prompt our user, and we're going to use the console.clear statement first. This will clear the console screen. We haven't used it a lot because, surprisingly enough, Hypergrade hates it. It will make Hypergrade crash. So we've just kind of stayed away from it. But since we won't be turning this one into Hypergrade, we can use it. Now, after we clear that console, let's do a write line. And what I want to write out here is a prompt for our location. So we'll just say location. Let's read that in to our location variable. Now that we theoretically know our location, we can use that location to prompt for the dates. In our application, we've decided things are going to work best if we know how many different sightings the user is planning on entering. So we're going to ask them how many sightings. We've asked them the location, so like they've said Florida. Now we're going to say how many. We'll say, well, 5 different days that we saw manatees. So this prompt is going to say something to that effect. How many sightings for, we'll use a parameter of 0, and we'll replace that with our location variable. So if my location is Florida, I should be saying, how many sightings for Florida? And of course, you can change that to one of the interpolated strings, but it's always good for us to use the different kinds, kind of remind us that all these different options are available. Now, let's read that in. We'll declare a new string called InValue for our read line.
Is there a reason why we aren't using the status.console?
No, we could.
Okay.
So yeah, just another way for us to make it a little bit different, just to keep reminding you all those things are possible. And it's totally fine if you want to change it. Okay, so we read in this input value that should be a number. So in this example, they want to use the if statement to validate that integer. So we're going to validate InValue. If it parses as an integer, we're going to output it into our loop count variable. If it doesn't, it's going to throw a false, and we're going to output a message. Invalid data entered, space hyphen. And then we're going to say 0 entered, recorded for number of sightings. Now notice how they're doing this a little different. You guys have had this thrown at you so many different ways. In your data validation for that last assignment, the enter scores, even though you were working with arrays and you had to worry about arrays too, the data validation is a really challenging part of that, and it always is, because we're always trying to figure out the best way to do that kind of stuff. So here they decided they're not going to do a where loop and keep prompting for that data over and over. They're just going to give them one shot. If they enter it right, great, we'll use that number. If they don't, we'll take a 0, and then we probably won't ask them for much more information, will we? So that's just a choice, and it's a matter of how we want our application to work. Now that we've got that set, we know how many different sightings have occurred at this location. So let's use that to run a for loop. In our for loop, we don't need to declare our integer named I because it's already declared. So we can start by saying we want to set I to 0. We want to run while I is less than our loop count that the user just gave us. And for each execution of our loop, we want to add to I. Now within our for loop, let's prompt for a date. So console.write, we're going to say enter a date, just the word date actually, and then we're going to suggest a format. Month, / day, / year. Now, when they type something, we're going to take that in as a date. So we're just going to add it directly to our date array. We're going to put it right into the position in our array pointed to by our I variable. So whatever we read in, we're just going to put that in that date array. We do want to make sure, though, that some data was entered. So we're going to do an if statement. And we're going to look at that entry in our data array at position I. If it's equal to an empty string, then we're going to output an error message. No date entered. And then I'll put unknown. That's spelled right. Unknown recorded for sightings. Bless you. And we're going to change our D array entry at position I to be equal to the word unknown. So when we said we're going to record unknown, we were not kidding. I'll make it an uppercase unknown because we might be checking for that someplace else. So now as we go through here, we're going to add a little bit more code to ask them how many sightings occurred on this date. And then the return value we're going to send back to the caller was how many sightings there were. Let's test this before we add the rest of that code in. I'm going to label the end of that if statement and the end of the for loop, and then the end of our get data method so that we can find our spot easy when we come back. So let's go to our driver, our tester. We need to get some things set up in it. So I'm going to go to our Manatee. Oh, we're already in it. Sorry, I'm trying to go to the other one. We're in the Manatee app class already. Let's go up to the top to our main method. Now in our main method, we need to declare some variables. For us to properly test this application, we're going to need a string to hold the location. We're going to need an integer to hold how many sightings there were, our sighting count. And then we're just going to kind of have arrays everywhere. So in our main, we're going to allocate an array of strings, our D array, and we're going to say that it's a new array of strings with 20 entries. If you want to put a comment there, allocate array with 20 entries. So we're going to use this array in our main for people to type the dates in. But then we're going to pass all of those dates that they type in that array to our Manatee sighting class, and it's going to save all those dates as part of that sighting. So we actually have the array in both classes. Now we need to do the same thing with our integer array, our Manatee count and it'll be a new array of integers, but we're going to keep it parallel with our dates. So if we say we went to Florida as our location, and we saw we had one manatee sighting, we would enter that date, and we would enter how many manatees we saw on that date. If we saw 3 manatee sightings, we would have 3 different dates with 3 different counts. Okay, so those are how our arrays are going to work. Now, one more data field is going to be a char data type, and we're going to use this to indicate whether our user wants to continue entering data. We normally use a string character for this, so it's great for us to try something different. Using a char, now because it's a char data type, I'm going to use single quotes to set up that initial value instead of double quotes. So our char data type uses single quotes. And then finally, we would like to have a variable to hold an instance of our manatee sighting. We're going to set that up, and we're going to call it M. It's going to be a really short name. So that'll be an instance of a manatee sighting. So last time when we tested, we called our instance Site1, right? It was an instance of a manatee sighting. We said it was just Australia. Up here, we're going to call that instance M. So it'll be a real short name. Now we don't need the test stuff that we had anymore. So let's delete those 2 lines of code that have to do with that Site1 instance. So now we should have our variables all declared. We want to go into a do while loop, and we want to keep executing that loop while our enter more data variable is a Y. So let's go ahead and enter that loop. Do. When I pressed enter, it popped all the rest of that code in there for me. So I can go ahead and type in my while condition. My while condition for this loop is going to be that enter more data should be equal to an uppercase Y. If that's true, I want to continue executing my loop. Now to simplify things, I'm going to add an or condition and say, or enter more data should be equal to the lowercase y. We haven't done a lot of ors, so if you can't find that pipe character, remember it's the shift backslash, so right above your enter key. Now, some things about using a char data type here. It doesn't change the way any of this works at all for us. One thing it does change, would we be able to use the .to upper on a char data type character? No, because the to upper is a string method, so we wouldn't be able to do that. Other than that, it should be pretty much the same for us except for the single quotes. All right, so my do while loop is pretty well formed here. At the end of the do while loop, the very last thing we're going to have is a prompt to ask them if they want to continue entering data. We'll add that in a minute. Beforehand, let's go ahead and create our first sighting. Now, whenever we use our get data method, it's going to return an integer for how many sightings the user said they were recording. So we're going to save that integer into our sighting count variable. So when we call our get data method, first of all, we're going to specify that our output parameter is our location. Then we're going to say, I also want to send in the D array and the manatee count array. Now that's going to call our method. And in our method now, all of these variables are going to get updated. First of all, our get data method is going to return an integer. So that's going to update the sightings count variable. We set the location variable as out. So that means whatever we type in as the location in that get data method is going to be updated to this variable in our main. Our arrays, since they're arrays, they're passed by reference, right, instead of being passed by value. So that means our main and our get data are both working on the same version of the array in memory. So basically, every variable that we have here in our main is part of this get data call is going to be updated by our get data. So we should be able to try it. Let's set a breakpoint so we can see what's happening in this thing. I want to set a breakpoint right here where we call this get data. Now remember, it can be kind of a super pain to use the debugger in the breakpoint when we're doing the console input. So we'll have to see if we can get it to work. I'm going to start my program. And here's my console. I'm going to try to put it kind of beside it. Now my breakpoint was set for when we were going to call our get data method. So right now I'm sitting there, my execution has been halted, ready to run that line of code. So if I click step into, we should see control transfer to our get data method. Sure enough, there it is. Now in our get data method, if you look at all of your argument data that's been passed, you should see that location is null. Your D array is allocated as 20 strings. Your manatee count is allocated as 20 integers. So we can see some things going on there even before we start typing any data. Now I'm going to click step into, and first it's going to clear my console. Then I should see the console.writeLine location. I'm going to run that line of code, and there it is. My location now is being prompted. So when I type something in, you might not be able to see it. When I type it in, press enter. Now when I click step into, you should be able to double check and see that your data did get into your location variable even though you couldn't see it. And I can see my Florida string. So even though it didn't show up until after I executed that line of code, it did work. All right, so the next thing it's going to do is prompt us for how many sightings were there. So again, I need to type something. I'll say 3 and press enter. And I'm going to execute that line of code and see if I get something. Sure enough, my in value is 3. And what I want to see is what happens when it goes into my for loop. Here's my for loop. It should start prompting me for those 3 different dates. There's my first one. I'll read it in. And there it sort of worked. I'll run that line of code so I can be sure my D array is the way I want it. And then if you keep stepping, you should see your for loop execute as many times as you said there were sightings. So if everything's looking good, you might want to stop that. This is one of those ones where I don't know if it's worth it to run it in the debugger because it makes us jump back and forth so bad it can be really super confusing. So we have just those things we have to worry about, but we can get around it and see that something is happening. So let's add a little bit more. Is everybody's okay there? Are you all right? Back and back, okay, okay, okay. Good, good, good. So let's prompt for the number of manatees that they saw on that date. So we want to add that right here in our for loop. I'm in my Manatee app CS file. I'm in the get data method, and I'm down in the for loop for the get data method. In the for loop, we've just put in all of the information to prompt for the dates that the sightings occurred. So after that if statement, I'm going to add some more code. And in this prompt, we're going to ask for how many sightings. It is going to be a console.write. And we want to know number of sightings. We're going to read that into our in-value variable. And then we're going to do an if statement again. If int.tryParse on our in value is numeric, let's output it to our manatee count array at position I. Now, if I can't parse it, we'll throw a false. And if we throw a false, we're going to do a console.write line. And say invalid data entered. Zero recorded for Manatee sightings. Now try your application, and for every sighting you say that occurred, you should get prompted for the date and the number of manatees that were seen. We're just building all of this input, and in this example, like you guys to see it, notice how they made this, bless you, they made this get data method kind of complicated, didn't they? We're seeing where if we make a method do more than one logical thing, it can actually be a little complicated. So this method might be easier to use if it was simplified. But right now it's a great example, and it shows us how we can use all these arrays and pass things back and forth. So I'm going to try to run it. Oh, I want to turn that off. I'm going to turn off that breakpoint because it was just being really hard to use. Set my location. Say I had 4 sightings. And let's see, 420. We saw 3 of them. And one more, 425. I'll say we saw 5 of them. That's it. So that made my loop work. I heard a uh-oh back here. Are we okay? What's the matter? In the get data, let me find it right down here. Does that look right? Okay. Well, it looks like now we've got all our data collected. We're ready to create an instance of our Manatee sighting, and then update its toString so it gives us more information. So to create our instance of a Manatee sighting, I want to go back to our main method, and we're going to have that happen inside of our do loop. Our do while loop right now is just asking about the information for our sightings for that location. So whenever we get done with all of that information gathering for a location, we're ready to create an instance of a Manatee sighting, our M variable. So we're going to say our M variable is a new Manatee sighting. Now we want to pass some information to our Manatee sighting constructor because we spent all this time asking for all this data. Let's use it. First of all, we have the location. Next, the date array. Next, the Manatee count array. And finally, for our Manatee sighting app, we also want to know how many sightings were there that day, that count. Now, when I set up this constructor, this call, I just went ahead and put each parameter on its own line. You guys can do it however you like. In general, when we're programming, I try and fit as much as I can on one line, but yet not go crazy so that you can't see it on the screen. But in reality, if I were programming for myself at work, I would use a style like this because this is what I prefer, because to me it makes it clearer for me to see all of the arguments that are being passed in as parameters. An engineer type person might despise it because it uses all of this extra white space that they feel like is just huge waste. I should have everything all squished together without even spaces between the commas. They're both valid. It's just a matter of preference. And that's a great thing about programming is you can do it the way that you like it. As long as nobody's arguing with you, you're good. So that's going to create a new instance of our Manatee sighting. After we create that instance, let's print out some information about it. So I want to do the console.clear. And then I'm going to use the console.writeLine to write out information about my M Manatee sighting. So remember, that's going to force C# to run the toString method in the Manatee sighting class because the toString method is the default method if we don't specify a method to run. Try to say that. Okay, so let's try it. I'm going to run this. My location will be Florida. How many sightings for Florida? Oh, I only want 2 because I'm going to have to type all that in. Now, it jumped right to the next prompt for a new location. So that's fine, because the next thing we're going to do is going to take care of us not being able to see that output. Let's fix it. After we do that write line, we're going to go ahead and output a message asking if they want another. And that's going to pause that console for us to see our output. So instead of us doing something else that's just temporary, let's go ahead and put that code in. We want to do a console.write to prompt the user to see if they want to enter more data. I don't know why, but they want a bunch of blank lines before that prompt. So do like 4\ns. 1, 2, 3, 4, yeah. And then we're going to say, do you want to enter more data, space hyphen. And then on the next line, we're going to say, within parentheses, enter Y or N. Now, when we read that in, we want to read it in as a char data type. So we're actually going to use the char.try-parse. We'll say we want to try to parse whatever came through from our console.read line. And we want the output to be placed into our variable, enter more data. Now, if that can be parsed as a char, our enter more data variable will contain the results. If it can't, we'll throw a false. If we throw a false and we didn't get good data, let's do a console.writeLine and specify, again, invalid data entered. No recorded for your response. So this morning, we wondered, what does C# do if we're trying to try parse a char data type and we can't? We know that if we're trying to try parse an integer and it fails, the output variable will be loaded with 0, right? So what does it do with a char data type to that output variable if the try parse fails? Well, we searched and we found it. It puts a number 1 in it, is what we found. So it definitely won't be a Y. And in our loop, since we say we only want to continue looping if it's a Y, we're safe. Okay, so anything that's not a Y, or even if they just press enter, it'll end our loop. Beautiful. Let's try it. To Florida. I need to put a space in that prompt. It's bothering me. I'll say 2 sightings, 04, 01, 2019. We saw 4, 04, 13, 2019. We saw 3. Do you want to enter more data, Y or N? You can say Y and see what happens, but it's clearing our screen incorrectly. What is that? Do you see it? We're writing out our Manatee information here, but then we're not seeing it. So I'm going to put a console.read right there so I can see that output because something is not going right. I'm going to run it. Choose Florida. 2, 4/1/2019. 4 sightings. 4/20/2019. 8 sightings. That's all we're getting out of our read key is our location. So it's right, isn't it?
It's from the sighting class.
From the sighting class. Let's fix that. Let's make it output more information. So I want to go to our Manatee sighting, and let's find our read key. Whenever we put it in there the other day, we just output the location because there wasn't any need for us to get crazy with all of this other stuff they wanted. Now we need to add some of that other stuff. So after the location, let's add more. The first thing we want is 2 new lines. And we're going to output this string, average number of sightings. Bless you. After our average number of sightings string, we want a tab character. Then I want more. Now, right here, I'm going to put a comment and say, here is where we should call our calculate average. We don't have that method right yet. Next, we're going to output some new lines and the month name for the, I'm going to keep going, new line, date of most sightings, and 2 tab characters. Now, after that prompt, that's where we're going to call our get month with most sightings method that we don't have yet. Two more new lines. And this prompt should say date of most sightings. And then 2 tabs. And of course, that's where we're going to put get date with most sightings. We have a long 2 string, don't we? One more, we're going to output count for and then finally at the very end, just a sec, we'll do our colon. And we're going to have a few places where we'll be doing some calls. Yes, huh?
You did date of most sightings twice.
Okay. No, I did a prompt for it and then a comment that said that we're going to need to call it.
No, but then up above it, you have date of most sightings, line 83 and new time.
Yeah.
Oh, month's name for the date of most sightings.
Mhm.
And date of most.
Yeah.
And then under date of most sightings, we have also got date of most sightings.
Yep, I do. That's what they want.
Okay.
You can change it, but that's what they want. So let's run it. Now we should get a little more output. But I do want to go up to our main in our Manatee app and get rid of that read I added.
Can you go back to the 2 strings?
Sure, you bet. It's kind of giant, isn't it? There you go. I thought you guys were doing amazing. You're getting it. It's ugly.
Yeah.
Isn't it? It is not the way you want to do it, is it? I'm hoping you guys can be thinking of all sorts of better ways. Huh? That would help.
When you said get rid of the read,
In the main method that was just right in the middle of that loop. This is a big one, and I know for me it's hard as an instructor because it's so involved and you guys have to focus so much to get it done. So I was kind of stressed about it, and this morning I had a few people say it really helped them kind of bring some ideas together. So stick with it. It's a bit of a bear for sure. We like to do those little fast applications, but that doesn't give you guys a chance to really pull all the pieces together. We'll get a chance here. Okay, let's run it. Florida, 2 sightings, 4/1, 2019, 5 things, and 4/3, 2019. I saw a set 4 manatees. Now I'm getting some information. I'm seeing that my toString is outputting more data. It's telling me the location, but then we don't have any other information being supplied to our toString the way we need it. So we need a few more methods because that toString wanted those methods like the calculating the average and stuff like that. While we're here though, let's test our enter more data loop. We should be able to say why, and it should start over asking us for a new location. I'll do Australia, and I'll say one sighting in Australia, 4/1/2019. We saw 26 manatees, and then I see that my toString is running for my Australia. Now, if I just press enter, because we're doing that try parse, it should go ahead and end the loop. When I press enter again, you'll see it. Okay, so let's add our calculate average. That's the first thing that we want in our output is the average. You guys have saw, I don't know if that's proper English, you saw as you were working on the assignment that was due last night that you had to worry about the size of that array, didn't you? It said to make it 100, but if you made it 100 and they only typed in 7 grades, then you couldn't use that average function with the array thing, right? Could you? Because it said you had 100 entries, and so that the math didn't come out right. But yet, you just keep getting in this terrible mess of, well, what do I do about these ones that are in the array but don't count? And that's something that we always have to worry about. So you were right to be concerned about those things in the assignment. And they're concerned about that same thing in this application. So as we calculate our average, they have a special way of handling it. They're going to create a special method called test for zeros. And then they're going to use that in their average calculation. So let's create that method first. It's going to return an integer. And like I said, it's named test for zeros. I got to say, I saw some of the best ways of handling that issue this semester that I've ever seen. I did see that one go-to, though. Don't use go-tos. Don't use go-tos. Don't do it. Huh? Thou shall not go to. It's go straight to zero. It's kind of like playing Monopoly where you get that go straight to jail. Go-tos are go straight to zero. You just get a zero. Okay, so let's declare an integer. That's right. We're going to declare this integer as number of true sightings, and we're going to set it equal to 0 to start. Then we're just going to use a for each loop. And in our for each loop, oh, I pressed tab, by the way, to get all that stuff that was generated for me. The collection that we're going to be using in our for each loop is going to be our manatee count array. Each thing in our manatee count array is an integer. So I'll make it an integer there at the beginning. Then the variable name, I would like this variable to be named CNT for count. Because remember, each thing in our manatee count array is a count. How many did we see? Now in that for each loop, if what we're looking at for that entry, our count, is not equal to 0, we want to add 1 to our number of true sightings. That's it. We can go ahead and return our number of true sightings variable. Now we've looped through that array, and if our manatee count was set to 0, we didn't count it. Because even if they went to the trouble to enter it and enter a date and things like that, it wasn't really a real sighting because there weren't any manatees involved. So we're just going to call this little method to get this true sightings count. So we're going to call it in our average. So let's create our average method. Make sure that your region statements are in the right place in relation to where you're putting these methods so that you're putting them within your instance methods region. Okay, so our average is going to return a double. We're going to call it calculate AVG. It doesn't need any parameters sent to it because it's going to just use our class data variables. Notice how setting up our class can really simplify all of the parameters and stuff that we have to do, because since we've got those class variables that we can access in any method, we don't have to be passing that stuff around all the time. Okay, so in our calculate average, we're going to declare a double variable as our AVG, our average, an integer count of valid entries, another integer to hold our total, and we want to initialize it to 0. And then we're ready to start looping through. So again, we're going to do a for each. Now this for each collection is again going to traverse our manatee count array. The variables in our manatee count array are integers. For this for each loop, we're going to call those integers C. And in our for each, we're just going to add that count to our total. Now, I did see some people really utilizing their for each logic and trying to figure out how to solve that problem with those grades. So that was a great way to handle it. Now, we want to use our test for zeros method to return a count of our valid entries. So we'll just call our test for zeros and take the output that it returns to us. And then we can finally calculate our average. It's going to be equal to our total divided by our count of valid entries. And we can return it. So why have I got the baby blue squiggly? Loss of fraction. I don't have any fractions. What's it talking about?
Meaning if the division the division isn't a whole number, it'll convert it to an integer. And can also
So what should I do? Casting it as what? A double. Great. Oop. Got into insert mode somehow. It's actually typing the keys that I was touching, even though it's trying to blame the keyboard. This keyboard must be broken. Okay, let's try it. Is it working? Now we should be seeing our average show up in our output, our average number of manatees per sighting. I'll run it to see. Say it's Florida. 2/4/1/2019 we saw 4 manatees. For 2019, we saw 8 manatees. It didn't show up. Didn't we create all that code? We didn't call it. We have to call it too. After all that work, doesn't it know we wanted to do it? To ask you guys those important questions. So let's look at our main. Oh, it's not in our main. Where is it that we needed to call that? ToString. So we left that comment in. So right where we left that comment, let's put in that call. Let me get it here. So we're just going to call our calculate average, and then we're going to take the output and convert it to a string, and we're going to make it a fixed point number with 1 decimal place. Now at the end of that line, I need to add the plus sign so that it fits back in with our string building. You find it? That looks good. Let's run it. Now we should see our average. Florida, 2 sightings, 4-1. We saw 5 of them. 4-15. We saw 8 of them. That looks like a good average. What do you think? Is that right? My daughter doesn't want to see manatees. She actually wants to pet sea turtles because sea turtles are supposed to bite, and so she wants to see if that's true.
Why? All turtles bite.
She's just got a need to know sometimes. Yes, she might come back with 1 finger less. She actually mentioned that. I like the sea turtles too. I would want to swim with sea turtles. She doesn't believe they would actually bite her. You know how everybody is. Okay, is it working? Is it working? Oh, Manatee app, man. We haven't done any like this big. What you got?
For some reason, it's spitting out an error for my test for zeros.
Do we run into project? Can you project so we can all look? Let me turn it off so you can do that. Okay, it should let you. It's just so much better if we all look at it. Can you guys see it?
You have no return statement.
No return statement. So it should go right after the end of your for each. And we want to return that number of true sightings, right? Good. Thank you, guys. Okay. Awesome. Now, when you look at that PDF document, when you find this application, remember it is on in Chapter 7 at the end. There are more methods that you need to add to your Manatee Sightings class, like how to calculate or how to find the date with the most sightings and what date that was. We're not going to go through all of those together, but I'm going to recommend that you do that on your own. Now, to facilitate that, we better check this stuff in the way we've got it. So when you get home, you'll have all this code. So I have already added this to source control and checked in earlier. So I'm going to check it in again. And I'll say this is after calculate average, and then check it in. Now, once it gets pushed to TFS, I could go to Team Explorer and go home and look at my Source Control Explorer. And now if I look at that project, my Manatee app, you could look at all of the check-ins for that item and you would be able to see those comments.
How do you do that?
Yeah, I don't know. You had to look. Oh, view history. That's what we want. So if you view history, it's the little clock icon. So you can right click and find that icon, or it's in your toolbar. When you view history on one of your applications, then you're going to see all of the different times that it was checked in. Is it change set? You'll see your comment when that check-in happened, so that you can move around in your code. Now I know that. Make sure you can find it all and do all that great stuff. And I'm going to bring up our new textbook, which I know we haven't used a lot. But this chapter, chapter 7, is actually pretty good in your textbook. So let me see if I can get a picture of it here for you to see so you remember what it looks like. Everything's being super slow. It's not just me. Okay, so our book, this one, do you remember it? Do you have it at home? Is it somewhere under your coffee table? Holding up something? Because it's John. I'm so scared
I
of you.
almost took mine out of my bag.
He's got it with him. He's using it for exercise.
Mine's under my mom.
Is it? Yeah, I mean, it really works for stuff like that. Huh?
Is that not a coaster?
It's giant, isn't it? I was actually trying to read chapter 7 because it's got good stuff in it. It's so huge. I was reading it at night, and you have to go get it and pick it up and take it into the bed because you can't just reach around and pick it up or something. Once you're in there, it'll break you. It's really something. Okay, so chapter 7 is good. So some of those early chapters, not so good. But chapter 7 talks about, let me get, oh, come on, reset this thing. Chapter 7 talks about exceptions and then kind of have some nice examples. So let's look at their examples real quick and see if we can look at an exception. We have enough time, and I'm going to kind of push you today so that we can take a look at it because we need to. So I'm going to send some CS files to you via the chat. In Visual Studio, let's create a new project. Now on your new project, go ahead and check the box to add it to source control. Make sure it's a console app. And let's name this Chapter 7, Simple Exception. And this is really what the project is named in your textbook. Now, our Simple Exception project is actually going to use a little class they create for a car. So let me send that to you. So there's your car, and the car has a radio. So I'm going to send you the radio.cs file and the program.cs file. Now, if you're not already in the Zoom session, you're not going to see those items in the chat. So you'll have to ask for them. Now, I am sitting here where I've saved those files. So the first thing I'm going to do in my program is I'm going to open the program.cs file, and I'm going to select all and copy. And then in my project, my new project I just created, I'll select all and paste. Now I'd like to add the other two classes. So in my Solution Explorer, I'm going to add a new class file to my project. For the car. And of course, if you've already saved this CS file somewhere, you could just add an existing file and go select it and pull that into your project that way, and that would be a lot better than copying and pasting if you have it saved somewhere. There's my car class. Finally, I want to add a radio class. My radio class is super small. I'm going to copy it and paste it. Now, you should have all three class files in this project. Let's take a look at them, starting with the car. Now, looking at your car class, notice that it's formatted a little different than the class files that we've maybe been working on, but you can still see what's going on. Our car class starts out with a max speed variable. That's kind of a constant. You notice we can't change that, we can't do much with it. Then we have some properties, some getters and setters. Notice that our car class doesn't have any private class fields. It only has public properties, right? So that's not necessarily recommended, but it'll work. We see an example here. Now, we do have a private class field to tell us if the car is dead. And we do have a private instance of a radio that we've called the music box. Now, in our constructors for our car, we can either have a no-ARG constructor that'll create a blank instance, or we can have a constructor that uses the name of the car and how fast it's going. We have a method here in our car class called crank tunes that takes our radio and turns it and uses the turn on method to change the state, either true or false. And then we have an accelerator method. We're going to come back to that. Let's leave that for now. Now look at your radio class. In your radio class, again, we only have this one method, turn on, and it uses a Boolean. If we pass it a true value, it's going to display this message that it's jamming. If we pass a false value, it's going to display this message that it's a quiet time. So that's all our radio does. Now our program file, our tester, writes out some messages, and then it creates an instance of our car. And it says that the car name is Zippy and its speed is 20. Then it uses that car instance to crank up some tunes. Then it starts using this logic we haven't seen before, the exception handling. You saw it a little bit last time, depending on how much you looked at that code that you copied and pasted to turn in. Whenever we're doing exception handling, we're going to encase the code that we want to check for an error within a try block. And a try block just gives us a way to try to do anything we like. Try to open a file, try to access a database, try to do all of the code. If an error occurs in all of the code that we're trying within this try block, we'll use our catch to catch that error and do something with it. So instead of that error exception splatting all over the screen and causing an operating system exception, scaring the user, not knowing what to do, we're going to catch that exception and keep it away from the operating system. We're going to handle it ourselves. And we're going to say, oh, we're going to write out some information about the error that we encounter. Now, the kind of exceptions that you guys have seen so far have been things like divide by 0, try to convert a non-numeric number to an integer. All of those kinds of things have caused exceptions, and we've just let those exceptions happen, right? And then we've tried to figure out ways in our code to prevent them. Well, now we're to the spot where we're saying exceptions will happen. What are we going to do to catch them and to make sure they don't disrupt the operation of our system? So let's run this thing. So here we are, we created our car, and then we called that radio function. So we see that jamming message that came out. Then we go into our accelerate method. Our accelerate method just keeps looping, trying to increase the speed of the car. Once the car gets to the point where it has exceeded that maximum speed that we saw that was set in that car class, we throw an exception. We can't handle it. The car is dead. So in our code, we're sending a message saying, Zippy is overheated. We don't know what to do. There's been a problem. So let's look at our car class. In our car class, in our accelerate method, once our current speed is greater than our max speed, we create an exception. So we say, I want to create a new exception. Pet name is our car name, and the message is going to be our car name has overheated. We can add more information to this exception, like a helpful link to find out information about it, some more data like the timestamp and the cause. And then finally, it's this throw command that actually makes that exception occur that we could catch and do something with. So we've got to look at all of those kinds of things to see what's happening. So as you go through this chapter in your textbook, you'll see a lot of really, really helpful information. This is the very first exception that they show you. They'll show you how to get really deep into it and create your own exceptions and really load up data so that problem solving can be made easier and people can figure out what happened in your program. Now let's go ahead and check this in so that you can get to it. And I'll say that's our first simple exception. I'll check it in. And we should be good to go. Now take a look at that and let me know if you have any questions about it. When we work with exception handling, if you notice, it's one of those areas where you're not going to get a lot of experience here in class. So you're going to need to go through the chapter for sure outside of class. That's why your homework is kind of already done, right? So you have time to go through that chapter so you can get more about it. But it's also something that's going to be more meaningful to you as you use it over time. And so that's why we don't spend a huge amount of time on the try-catch block, because as you use it, you'll see it's actually very simple and doesn't really have a lot to worry about with it. So if there's no questions, I'm just going to close it then. And I'll let you guys get out of here or fix whatever you need to fix. If you're having trouble with TFS, let me know so I can help you. Otherwise, have a great weekend.